So we're going to do a quick review on ionic bonding, starting from what are the ions that make up this bond. So an ionic bond is made from a metal, and it is made from a non-metal. It's when the metal transfers electrons to the non-metal. So they're going to go from potassium, the valence electrons, to the oxygen. So potassium, looking at the periodic table, is in group 1, meaning it has one valence electron. So it's going to have a charge of +1 as a cation. So we're going to put a +1 charge. Oxygen is going to be on the right side of the periodic table. Oxygen is in group 16. That means it has 6 valence electrons, and it wants to get to 8, so it's going to need 2 more electrons, and it's going to get a -2 charge. So now we have our ions. That helps us to determine the formula. So if we have potassium that is +1, and we have oxygen -2. There are 2 ways to solve this. The first way, being that you just add an atom or an ion. You add an ion every time to balance it out. Currently, you have +1 and -2. In order to balance that out, you would need some more positives, because right now it would be -1 if you just had a potassium and oxygen, one of each. So we're going to start by adding another potassium and see if we need anything else. So if I add one more potassium, now I have a +2 -2. So that is balanced out. And our formula would be K2, because there are 2 potassium. Because there's 1 oxygen, and you don't need to put a 1 after the oxygen. So K2O is our final formula. When we're doing the name of the compound, the metal stays the same in the name. So you always start with the metal. So we have potassium. And then when the non-metal, you're going to change the ending to IDE. It's typically the last 3 to 4 letters that drop off, but there are common spellings that you can look at beforehand for non-metals. So potassium oxide. So you're adding the IDE at the end of oxygen instead. Oxygen becomes oxide. Now we're going to look at finding the mass. We want to find the mass for K2O. So 2 potassium, 1 oxygen. So what we're going to do when finding the mass is, first I like to know what the masses are of the elements given. So here we're going to round to the nearest 2 decimal places. So 39.10 grams for potassium. We always start with our metal. So 39.10 grams. We're going to add oxygen. So if you round 15.999, that rounds to 16.00 grams. So I have my 2 masses. Now I need to look at the quantity. So I'm going to have 2 potassium. So what that means is I'm going to need to put a 2 in front of the mass of potassium. And I'm going to multiply 2 times 39.01. Or 39.10, sorry. So 39.1 times 2 is going to come out to 78.20 plus 1 times 16, because there's 1 oxygen. So our final answer is going to be 78.20 plus 16. So it's going to be 94.20 0.20 grams is the mass of K2O, or potassium oxide. Potassium oxide, when drawn, you're going to have 2 potassium, and you're going to have 1 oxygen. And when they get together, the ions are going to have partial charges. So you'll have a charge here. We have O minus 2. Then we have our potassium is a +1 charge. And we have another potassium with a +1 charge. Since the electrons are transferring from the potassium to the oxygen, they're each losing 1 electron, and oxygen in total is gaining 2. Another thing we're going to look at is the properties of ionic compounds. So one thing is that ionic compounds are forming crystals. That's a repeating pattern of your basic compound, the smallest ratio. So a repeating pattern of that forms crystals. Most of them for ionic compounds are also referred to as salts. So they form crystals and they're referred to as a salt. Ionic compounds have high melting points and high boiling points. So think of adding salt to pasta water, how it changes how fast it boils, or the temperature at which it will boil. So high temperatures are required to overcome the forces. So that positive and negative ion, it takes a lot of energy to break that bond because opposites attract. So that positive and negative are so attracted that they don't want to break apart. So it takes high melting and high boiling point to break those two apart. Lots of energy and heat. They are hard and they are brittle. Thinking of crystals or, again, salts. So salt, you can break salt relatively easily. They conduct electricity when they are dissolved in water. So that means they are soluble. When they dissolve in water, the ions dissociate. So that means they come free and they're a positive and negatively charged ion in the solution or in the water.